Hey, welcome to The Explainer. Today, we're going to peel back the layers on blockchain technology and figure out what actually makes it so incredibly secure. And, spoiler alert, it's not just one thing, but a whole bunch of brilliant ideas all working together. So let's kick things off with a fundamental problem of our digital lives. How can you prove you own something or safely send it to a total stranger online without some big middleman like a bank or a credit card company taking their cut and holding all the power? It's a huge challenge, and it's the very problem blockchain was built to solve. For most of human history, we've had to rely on central authorities. Think banks, governments, you name it, to keep track of who owns what. They were the scorekeepers. But blockchain comes along and says, what if we could do this differently? What if trust could be built right into the system itself, using just math and code? And this slide right here just nails the difference. Over on the left, you've got the old way. One central ledger, one single point of control. If that gets hacked or even just goes offline, the whole system is in trouble. But on the right, that's the blockchain way. Instead of one master copy, imagine that everyone in the network has their own identical copy, and it's all magically kept in sync. Okay, so that idea of everyone having a copy, that brings us right to our first big layer of security, the decentralized network itself. Just by getting rid of that central point of failure, you're already making the whole thing way more secure. And the benefits of doing it this way are, well, they're massive. Since the record book, the ledger, is spread out across thousands of computers all over the world, there's no single server for a hacker to attack. I mean, if you try to cheat and change a record on your personal copy, it's not going to match up with what everyone else has, and the network will just instantly reject your version. It makes the system incredibly tough. Okay, but that's a great question, right? If I have a copy of the whole thing on my computer, what's stopping me from just opening it up and editing it to make myself a billionaire? Well, the answer to that lies in our next and super powerful layer of security. All right, let's peel back another layer of this onion. We're going to move from the network structure to the data itself, to the cryptographic glue that holds this whole ledger together. And this is where a concept called hashing becomes just absolutely essential. So what in the world is a hash function? Well, the easiest way to think about it is like a super unique digital fingerprint machine. You can feed it anything, a sentence, a document, a whole list of transactions, and it spits out this one-of-a-kind code called a hash. Let's take a look. If we pop the sentence, "the explainer is awesome," into a common hash function called SHA-256, we get this very specific, unique string of letters and numbers. And it will always be this exact hash for this exact sentence. No exceptions. But here's where it gets really, really cool. Watch this. We make one tiny, almost invisible change. We just add an exclamation mark to the end, and boom, the hash is completely and totally different. It's not just a little bit different, it's unrecognizable. This incredible property has a name. It's called the Avalanche Effect. A tiny little change in the input causes a massive, unpredictable change in the output. And that's what makes it so powerful, because it means you can't secretly tamper with data. Any change, no matter how small, screams for attention. Okay, so how does this fingerprinting idea actually secure a blockchain? Well, it's pretty brilliant. Each new block of transactions that gets added doesn't just hold the new data, it also holds the unique hash, the digital fingerprint, of the block that came right before it. So you end up with this interlocking, cryptographically linked chain. And here's the kicker. If a bad actor tried to go back and change just one little thing in an old block, its hash would instantly change. That would break the link to the next block, which contains the old hash, and that would break the link to the block after that, and so on, all the way down the line. It's a domino effect, and the rest of the network would immediately see this broken chain and reject it. So the chain makes the history of the ledger basically impossible to change. But what about adding new stuff? How does the system know who is actually allowed to make a transaction in the first place? This brings us to our third layer, managing who gets to write to the ledger. Well, the answer is this really clever system called public key cryptography. You might also hear it called asymmetric cryptography. And the big idea here is that instead of everyone having just one password, every user gets a special pair of keys that are mathematically linked together. One is public and the other is private. I love this analogy. It makes it so clear. Think of your public key like your home mailing address or your bank account number. You can give it out to anyone, right? It's how people send you stuff. But your private key, that's the only key that can actually open your mailbox and get what's inside. It's the key to your safe. You guard that with your life and never, ever share it with anyone. So when you go to send some crypto, what you're really doing is using your secret private key to create a unique digital signature for that specific transaction. Then, the whole network can take your public key and use it to check that the signature is legit, that it could only have been made by the person holding the matching private key. It's pure mathematical proof that you are who you say you are, all without ever revealing your secret key. It's amazing. All right, so let's recap. We've got a decentralized network that's resilient to attack. We have a hashed chain that makes the data tamper-proof, and we have cryptographic signatures to control who can make transactions. That is a seriously solid setup. But, technology never stops moving. So, what's next? Man, one of the areas that's just blowing up right now is something called zero-knowledge proofs, or ZKPs for short. The name sounds wild, but the concept is just mind-blowing. It's a way for you to prove that you know something without revealing the information itself. Imagine proving you're over 21 to get into a bar, but without ever showing the bouncer your actual birth date. That's the kind of privacy and security this could unlock. And even within ZKPs, it's not one size fits all. You've got these two big approaches, SNARKs and STARKs, and they each have their own pros and cons. SNARKs, for instance, create really small, efficient proofs, which is great, but they often need this complicated thing called a trusted setup to get started. STARKs, on the other hand, make bigger proofs, but they don't need that tricky setup. And, this is a huge one, they're believed to be resistant to attacks from the super powerful quantum computers of the future. That's a massive deal for long-term security. And all this constant innovation really brings us back to the main point, right? Blockchain security isn't just one static thing. It's this living, breathing, multi-layered defense system that's always evolving and getting stronger. And that leaves us with a really important question to think about. As our computers get unbelievably fast and new threats pop up, what's that next layer of security that we're gonna need to invent?